Alright, graph each equation on your calculator using polar coordinates. State the coordinates of the center and state the radius. Write a description of each circle comparing its location to the pole. So, you have number 1, r equals 2 sine of theta. I would like you to type that into Desmos, please. So, r equals 2 sine. And then your theta, if you hit the ABC, you can either write out theta and it'll turn into the symbol, or it's right above the backspace sign right here. Does everybody see on their screen what I have on my screen? Are we good? Okay. So on your graph, let's come back to your packet. What I would like you to do is I would like you to graph that. What do you notice about the center? Where is the center at? And if you need to zoom in, you can zoom in. The center's at 1 what? So hold on, remember, whenever you're doing this, our coordinates are r theta. So where is my center at? 1, pi over 2 or 90 degrees. Either one of those. What is the radius of this circle? 1. How do we know that's the radius? Because what's the diameter? 2. So the radius is 1. And now I would like you to draw this circle on this right here. Please try your hardest. I know I'm not great at it either, to draw a nice pretty circle. Personally, once I draw my initial one, I kind of go over it to make it a little bit more or less oval-y. And then I'm going to label this problem number 1. How does this center, or this circle, compare to the pole? What is the pole? The origin. So the center is 1 unit above the pole. Write that down, please. The center is 1 unit above the pole. We're just missing Alana. All right, what's going to happen if I do number 2? Number 2 is r equals negative sign. So if I add that negative, what happens? It kind of reflects, right? So where is my new center? So you can write either 1,270 or you can write negative 190. Those are the same point. So I'm going to write 1,270, but you could write negative 190 if you wanted. Ooh, that was better, but not as big. What is the radius of this circle? 1. And this time, the center is 1 unit below the pole. What questions do I have? I'm going to give you 2 minutes. I want you to do 3, 4, 5, and 6. Go. You do 3, 4, 5, and 6. Go. 3, 4, 5, and 6. When you are done, look up to see if your graphs and descriptions match mine. Yes, ma'am.
What did you get by this?
Yes.
What did you put in the calculator?
Yeah, so I just put in right here R equals 2.
Oh, okay.
Yep. Does that make sense? And then when you put in -2, you get the exact same picture. Nothing changes. What questions do I have? Can I move on? All right, what do we notice? Do we notice any rules, any trends? Yes. The number in front of sine or cosine determines the direction, potentially, right? Let's talk about that number first. What else does it determine? It actually determines one other thing. Like, let's say, in the quick check, number 1, it is R equals 7 sine of theta. Without typing this into our calculator, could we figure out the center and the radius? Does anybody want to guess what the radius is going to be? Well, these were all what in front? And what was my radius here? So if this is 7, what do you think the radius is going to be? You were right, Jenny. It is 3.5. You just take half of that number, and that's your radius. Now it's 7 sine of theta. What direction is this going to go? Why up? Because it's sine. Sine is your y, and it is positive. How many degrees is up? 90. So my r theta would be 3.5, 90 degrees. A little hint or a little graphic to help you. If you have a positive cosine, because that's x to the right, negative cosine goes that way. Positive sine goes up and negative sine goes down. Say that again. We are not going to use tangent at all in any of these? Yeah.
But there is a tangent.
We are not using tangent when polar graphing. Anything's possible, but we're not going to do it. Okay, I would like you, I'm going to give you 1 minute to do the other quick checks. I would like you without your, I would like you without your calculator to see if you could figure out this information. By the way, I'm just writing these, they're from your yellow paper, where it says a quick check. That's where I'm copying these from. Oh, it's supposed to say R equals. Let's see if you can find the radius and then give me the points. Look up, did you match my radii? For the R equals 1, it is just that radius. You don't cut it in half. It's telling you what the radius is. And if it's R equals a number, what's my center? 0, 0. Alright, for my next one, R equals -8 cosine. We know the R is 4. What direction does this go? Left, which is 180 degrees. By the way, I meant to say, somebody asked me, well, could I put, the radius is 1, could I put 1, 0 right here? That's not the center, though. This is asking for the center. So it's 0, 0. Alright, for this one, R equals -10 sine. What direction is that? Down, which is 270. And then R equals 3 cosine of theta. We know the radius is 1.5. What direction? It's +3, so it's going to go right. So it's going to be 0 degrees. Is this making sense? Okay. Are you in the College Board Desmos? If you're in Texas Star, this next part, it will not work for you. Texas Star doesn't graph secant. Okay? So, we are now going to do the same exact thing. Yeah. Oh, okay. So, in this case, a good question. You could write 360. Just be careful on like homeworks and things. This does not give you an interval, does it? If it were to give you an interval, just make sure that that interval doesn't look something like this, because if it did, then it does not equal 360, you couldn't write it. But if there's no interval, yeah, you're good to write 360 on it. Yep. Okay. All right, now we're going to test out this one. R equals 2 secant of theta. Let's type that in our calculators. R equals 2 secant of theta. What do we notice? All lines are straight. What kind of line is it? It is a vertical line that is where? That's to the right at 2. So what I would like you to do is go right to, and I want you to get your badge to draw said vertical line. If you give me a line that's not straight because you tried to draw a line without using a straight edge, I'll count points off. Get your badge. That's the easiest, most accessible thing. If you don't have a badge, you have a paper badge, you can always go get a protractor from my shelf. My line is straight. Okay, it's straight. It might be slanted, but it's straight. I'm not picky about that. But what does matter, it's a line. What must it have? If you do not have arrows, I'll count points off. It is straight. It might not be vertical, but it is straight. Those are different. Let me redraw it. It was straight. Is that better? Yeah. Okay, thank you. There we go. Okay. This part, if you read the instructions on B, it says graph each equation, write a description of the graph comparing to the polar axis. Y'all, what is a polar axis? What? What's the polar axis? Good question. It intersects the pole, but it's not the pole. Do y'all see how I have a bolded line on every single problem? That is your polar axis. We wrote that down 2 days ago. All right, what do we notice about this line and the polar axis? They are perpendicular. So you would say the line is perpendicular. Y'all, I'm lazy, so I'm going to do the symbol for perpendicular. If you don't know that's the symbol, write down the word perpendicular. But it's perpendicular to the polar axis. And then it also wants us to state the polar coordinate of the point that the line passes through. So where does this line pass through the polar axis at? 2, 0. What questions do I have? All right, what about r equals -2 secant of theta? If I do -2, what happens to my line? It's on the other side. Straight. My lines were straight. It just wasn't very vertical.
And that defeats the purpose of straight.
But those are different words. They have different meanings. And what about this line? I'm going to be extra lazy. Are y'all cool with me writing that? You can't see. Just kidding. Are y'all cool with me writing that? Do y'all know what that means? Same. Katie. All right, what point does this go through? 180. Write that down, please. You could also put -2, 0. It's not wrong. What about r equals the cosecant of theta? Number 3. Let's see. I'm going to take out my secant and change it to cosecant. And what happens? Brendan is right. A horizontal line where? Above it at 2. What point does this go through? 290. And what about this line? Write this down, please. The line is parallel. That's 2 L's. That's my shorthand. Well, everybody's shorthand. Phelan, you with me? You with me? Yeah. And then without using our computers, do y'all want to guess what's going to happen with negative 2 cosecant? The same thing as 3, but down. So what would be my point for this line? 270. By the way, if you don't have a degree sign on these points, that's points off. I'll probably ask you to do things in radians, but because this asks you to set them in degree mode, we're doing degrees. And then what is this line? It's parallel. Okay? Questions? When you're done writing this, turn to the next page. And I want you to do B quick check. So here's B. I want you to read these quick checks. You are going to graph them and then create the equation. So on your yellow paper, look at B quick check. Go. Me too. I just popped my back. Oh wow, you actually did work?
We had a lab today.
What class was it? Oh. With Miss Woon?
That's the only class I see this year. Well, I usually do like the majority of the notes, and then I'm just like, I'm done. And then I just go to sleep. I don't get the notes today. See. I can't find it still. I'm hungry.
Do y'all have 1 and 2 done or not yet? Did y'all graph them like that?
Yes.
What is the equation for number 1? 2 cosecant. Why cosecant? Because it's parallel. And then the other one? Perfect. Don't forget your R equals. And then because it goes left, it's negative. And just think, to remember which one's which. Secant is the reciprocal of cosine. Cosine is x. That's how you can kind of remember what direction. Any questions? Okay. Could I write cosine right here? No. Because cosine does not create a line. What does cosine create? A circle. Alright, be careful on this next one. Y'all listen. A line perpendicular to the polar axis that passes through the point negative 4, 0. Where is negative 4, 0? Go to 0 and go away. 1, 2, 3, 4. 4 away from 0. And then draw your vertical line because it's perpendicular. Alright, hold on, y'all. I'm almost done talking. Stay with me, please. What are we going to get here for the equation? R equals negative 4 secant theta. I went left 4. That is all you do. Last one. Shh, boys in the back. Shh. Negative 3, it's a parallel, and it passes through negative 3, 270. Where is that going to be? 270 degrees is down here. And I'm going to go negative, so I'm going to go away 1, 2, 3. So negative 3, 270. And what is that equation? R equals what? No, what'd you say after the equals? Okay, be careful. Negative 3 would go down. So it's just 3. So, boys. So I know it gave you negative 3. But just because it gives you negative 3 doesn't mean that your right here is going to be negative. It went up, so it's going to be positive 3 cosecant theta. Do I have any questions? You sure? Okay, last thing. I'm now going to read part C to you, so just look at your yellow sheet or look up. There's a third type of line that you are responsible for, but it cannot be graphed on a calculator. This line passes through the pole, or 0, 0, and is described using the measure of the angle formed with the polar axis. An example equation would be theta equals 30 degrees. This line would pass through the pole and make a 30-degree angle with the polar axis. So, if I give you an equation that's theta equals an angle, you are just going to draw a line through that angle. So, for instance, quick check number 1. A line passes through 0, 0 and makes an angle of 135 with the polar axis. Where is 135 degrees? In the middle, right there. Do y'all agree? So you are just going to draw a line from here through the pole, through the entire circle, and make sure it's a line, so make sure it has arrows. And that's it. And what's your equation going to be? No. R equals will give me a circle, because that's a radius. What is it going to be? Theta equals, and then that number. 135 degrees. What questions do I have? Can we do the next one?
No.
Number 2 says the line passes through 0, 0 and makes an angle of negative pi over 6 with the polar axis. What is where is negative pi over 6? 11 pi over 6. Where's 11 pi over 6? Be careful, don't graph the wrong one. Fourth quadrant, because you're going down. Negative pi over 6 is right here. Again, that's the same thing as 11 pi over 6. And you are going to draw that line. What is my equation going to be? I would accept either one of them. Isn't that technically also theta equals 5 pi over 6? Sure. Is that theta equals 330? Sure. Do you have a question for me? No? Okay. Any questions? I want you to try the last one on your own. Quick check number 3 for part C. Look up when you are done. Did you get it right? Okay. Do I have any questions? This packet, I've started you out. This packet is due on Friday when you walk into class. Tomorrow, you are going to come in and trade and grade your homework, and then you're going to start on the packet. I changed it. I wrote it on the board, but I forgot to tell y'all yesterday. Quiz B is going to be on Thursday, not tomorrow. So, you're going to trade and grade your homework. Tomorrow, you're going to work on the packet. You're going to come in Thursday, we're going to take Quiz B. You're going to work on the packet. And then whatever you don't finish, you are going to have to do for homework, because this packet is due for a daily grade on Friday. Okay? You don't do this packet, you're going to be a little bit lost for the next worksheet. Yes? Okay, we'll talk. All right, so you have 10 minutes left in class. I want everybody right now, unless you've turned in your homework, to get it out and start working on it. Last period I walked around and some people hadn't even started. That's an issue. I gave y'all 20 minutes yesterday. Everybody start working on it, or I'm taking away homework time for the